Hi students, welcome to today's class. So today I have taken the problems given in yesterday's that is the 30th January 2023 paper. So let us see some problems and their solutions. Okay. So the first problem I have taken is the eighth common term in the sequences. There are two sequences are given. In that sequences we have to find out the eighth common term. It is very clearly we are observing that the first common term is 11. Okay, like that if you go on writing, what will be the eighth common term? Okay, now first see what is the sequence given, what type of sequence is given, 3, 7, 11, so on. It is clearly an arithmetic progression, 3 plus 4, 7, 7 plus 4, 11, like that it is going. It is an arithmetic progression with the common difference 4. First term 3. Let us observe the second sequence, so on. This is also an arithmetic progression. Why? Because 1 plus 5, 6, 6 plus 5, 11, so on. This is also a arithmetic progression with the common difference 2, 5 and first term 1. Now, what will be the first common term 1? So, one thing you have to observe is, if there are two arithmetic, not only 2, 3, 4, whatever may be the arithmetic progressions, number of arithmetic progressions, their common terms are also in AP. That is the property that you should know. That means 11, next common term, next common term, next common term, all together they form an arithmetic progression. Okay, now? So, we know the first term. What is the first term? A is equal to 11. If you want to find out eighth term, we have to find out the common difference. That common difference is given by the LCM of least common multiples of whatever may be the arithmetic progression. So here what? First common difference 4, second common difference 5. What the LCM? Least common multiply 2. So this is the common difference of the common terms. Understand this? Now is asked to eighth term, not only eighth term, whatever may be the term we can find out. So therefore eighth term is given by A plus 70. A is equal to how much? 11 plus 7 into D. That is 11 plus 140. This is 151. So 151 will be the eighth common term. Okay, now. So here the thing is, you have to observe here LCM of the first, second, third, whatever may be the common sequences will be there. Okay, now. So very easy problem this is. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this second problem. So this second problem is from vector algebra. So very easy problem. So I hope that everybody will do this problem. Those who are taking seriously for the examinations, definitely they will do this problem. So very simple problem. If A bar and C bar are two vectors, there are two vectors such that, so modulus of A bar is equal to 1, modulus of B bar is equal to 1, A bar dot B bar is equal to 2, and the vector C bar is given as A bar cross B bar minus 3B bar, then the value of B bar dot C bar. So altogether here there are three vectors are there. For first two vectors, their moduluses are given, their dot product is also given. And the C bar is a vector, it is expressed in terms of A bar and B bar. He is asked to find out B bar dot C bar. Very easy problem. So we can do this. So this is a B bar dot C bar. So this is equal to B bar dot C bar, it is given clearly. So what is this? A bar cross B bar minus 3B bar. A bar cross B bar in place of C bar, we wrote this. Okay, now we know that dot product is distributive. Therefore B bar dot A bar cross B bar minus 3 into B bar whole square, B bar square, or B bar dot B bar. Okay, right. So clearly this value is 0. Why? Because this can be written as B box. We can write it as a box B bar, A bar, B bar. So in a box, if there are at least two equal vectors are there, its value is 0. Its value is 0. Now what about this value minus 3 B bar square? So this is given as minus 3 into b bar square is equal to how much? 4. That is equal to 4 square. That is a minus 3 into 16 minus 48. Therefore, minus 48 is the correct answer. So from this problem, the thing what you have to know is this is the vector triple product. So this is vector triple product. Okay, now dot product. The box of b bar, a bar, b bar is equal to 0. So if you make it as a 0, then automatically we will get the answer. Okay. So very easy problem. Almost it is a board level question. I hope that everybody will understand this solution. Let us move to next problem. Hi students, welcome to this problem. How many 7-digit odd numbers can be formed using the digits 1, 2, 2, 3, 3, 3 comma 3, 3 comma 3, 5. So total 1, 2, 3, 4, 5, 6, 7 digits are given. So using these 7 digits, we have to find out a 7-digit odd number. We have to find out a 7-digit odd number. Let us see the different cases. Odd numbers means we know 1, 2, 3, 4, 5, 6, 7. Okay now? So 1, 2, 3, 4, 5, 6, 7. 7-digit odd number. Okay now. Odd numbers means what? In the units place, 1 should be there, or 3 should be there, or 5 should be there. In the units place, 1 should be there, or 3 should be there, or 2 should not be there. Okay now? So right there, because if it is a 2 is there, then it will become a even number. Okay now, let us see this. See here 1, 2, 3, 4, 5, 6 places are there. In these 6 places, except this one, we already fixed here. First 1, 2, 3, 4, 5, 6. 6 places, these 6 digits can be filled in 6 factorial ways. 6 factorial, but here 2 is repeated 3 times. 3 is repeated 2 times. That's why this is equal to 3 factorial by 2 factorial. That is the repetition, permutations, repetition formulas are there. Total 6 digits, that is 6 factorial by 2 is repeated 3 times, 3 is repeated 2 times. Okay, now that's all. Now, coming to see the second case. Okay, afterwards we will find out those values. Coming to the second place, this is a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. In this, already 3 is fixed. Already 3 is fixed. Remaining these 6 places, 6 digits can be filled in 6 factorial ways by, now see here, 2 is repeated 3 times. But 3 is repeated 2 times, but it is already fixed 1, 2 is fixed here. That's why simply 2 factorial. 6 factorial by 2 factorial. Understand this? 6 factorial by, this is a 3 factorial. 6 factorial by 3 factorial. Understand? Again, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is also 6 factorial by, already here 5 is fixed here, this is already 5 is fixed here, 2 is repeated 3 times, 3 is repeated 2 times, 2 is repeated 3 times and 3 is repeated 2 times. Understood? So therefore total number is equal to, so that is a 6 factorial by 3 factorial into 2 factorial. This is also 6 factorial by 3 factorial 2. That means you can write down 2 times plus 6 factorial by 3 factorial. So let us calculate this. So this is equal to 2 into 6 into 5 into 4 into 3 factorial by 3 factorial into 2. Understand? 3, 4, 5, 6. Alright, we can cancel this 3 factorial also cancel, 2 also cancel, plus 6 factorial by 3 factorial means 6 into 5 into 4 into 3 factorial. 3 factorial will get cancelled. 6 5s are, this is a 120, this is a 120. 120 plus 120, 240. 120 plus 120 is equal to how much? 240. There are 240 odd numbers will be there. 240 odd numbers will be there. Understand this? So very easy problem. So the only thing in which area you have to concentrate? So you have to concentrate on the number of permutations when repetition of the items are there. Okay, so you concentrate more on that. Okay, so I hope that you enjoyed this solution. So let us move to next problem. Hi students, welcome to this problem. So here given the range of y is equal to root of 2 plus x plus root of 3 minus x is. So we have to find the range of y, that means the maximum value of y and the minimum value of y we have to find out. Then how to find out? The range means generally students, they will start finding the derivative. So first derivative dy by dx, and like that they will start doing. Otherwise squaring on both sides, we will get a quadratic equation in y, and thereby substituting and finding y is equal to minus b plus r minus root of, like that. Besides that, let us I will explain one concept. Let us see that concept, very nice concept. That is, what is the concept is, if any function is of root of x minus a plus root of b minus x, any function of the form y is equal to root of x minus a plus root of b, or x minus a plus root of b minus x, so that is here a is less than b. For this type of functions, so here it will be a, it is a x is equal to a, and it is a x is equal to b. The maximum value you will get here, so the maximum value you will get at x is equal to midpoint of these two, x is equal to a, x is equal to b, midpoint x plus a by 2, that is a maximum value, and you will get here minimum value. So at x is equal to a plus b by 2, you will get a maximum value, and at x is equal to b, we will get minimum value. Okay, now, so this is a short trick method we have. At x is equal to a plus b by 2, maximum value. At x is equal to b, minimum value. Why? Because here a is less than b. So let us take the given problem. So the given problem is y is equal to root of 2 plus x is there. Root of 2 plus x, can I write down x minus of minus 2? Yes. Root of 3 minus x, can I write it as root of x minus of minus 2? Yes. So this is your a value, and it is your b value, a less than b. First to find out x is equal to a plus b by 2. Here you will get a maximum value, that is a minus 2 plus 3 by 2, that is equal to 1 by 2. At x is equal to 1 by 2, you will get a maximum value. At x is equal to b, that means x is equal to 3, you will get minimum value. So this is equal to maximum value. It is not maximum value. At x is equal to 1 by 2, maximum value. At x is equal to 3, minimum value. Let us find out that maximum value and minimum value. So then how to find out maximum value? Root of, so wherever x is there, substitute 1 by 2. So therefore 2 plus 1 by 2 plus root of 3 minus 1 by 2. So this is 5 by 2. This is also 5 by 2. 2 root of 5 by 2. So this is equal to root 10. So this is equal to root 10. This is the maximum value, root 10. Then minimum value you will obtain at x is equal to 3. Wherever x is there, substitute 3. So therefore root of 2 plus 3 plus root of 3 minus 3. Wherever x is there, substitute x is equal to 3. So therefore this is equal to root 5. Therefore what is the range? Range is equal to minimum value comma maximum value, closure bracket. So root 5 comma root 10 is the range of this given function. Okay, so I hope that you understand this concept. Okay, so if you learn this concept, then this type of problems, only this is a helpful, useful for this type of functions. Okay, now, right. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. See here, if A1, A2, A3, so on, AK be an arithmetic progression. So A1, A2, A3, so on, AK be an arithmetic progression with the first term A1 common difference 1. Okay. First term is given, common difference is given, then the value of this equation is, so an expression is how much, then how to do this problem. So whenever this type of expression came, tan inverse of, so immediately you think of this formula, that is a tan inverse of A minus B by 1 plus A into B is equal to tan inverse of A minus tan inverse of B. Tan inverse of A minus B upon 1 plus A into B is equal to tan inverse of A minus tan inverse of B. So here 1 plus A1, A2, A into B is there. In the numerator, can we write it as a A2 minus A1? Why? Because nothing wrong in it. Why? Because here A2 minus A1 means what? Common difference. Second term minus first term, common difference. Here it is given that common difference is equal to how much? 1. That's why in place of 1, I can write it as A2 minus A1. So here also we can write it as a A3 minus A2. So there also we can write it as a A2022 minus 2021. Understand this? Okay. So from this tan inverse of A minus tan inverse of B, write down. So what we will get? This is equal to tan inverse of A2 minus tan inverse of 1 A1 plus next one tan inverse of A3 minus tan inverse of A2 plus so on. Next one tan inverse of A2022 minus tan inverse of A2021. Okay, now so any more cancellations? Let us see here. A2 minus tan inverse of A1. So what you will get here? See here, cancellation also you should be very careful. So this is a first bracket, this is a second bracket, and it is a last bracket. Okay, now then how? See here, tan inverse of A2, that means first bracket first term is cancelled with the second bracket second term. That is first bracket first term we are cancelling with the second bracket second term. Okay, now right. Next, like that, if you goes on like this, here also one bracket will come. Okay, now so here this term and the last term will be get cancelled. Last term will be get cancelled. So ultimately what remains? The term I will write down first one. This is a tan inverse of A 2022 minus tan inverse of A1. So these are general students will cut like that. No, you should be logic how they are cutting. So the first in the two brackets, here first bracket first term, last bracket. So definitely it will be remain. This will be cancelled with its previous bracket. Since there is no previous bracket, this will remain safe. So this will be cancelled with after next bracket. So next bracket is also not there. Next term is not there. That's why that will be safe. So only this term and this 2022 term will be safe. So let us write this as a, so therefore A 2022. Okay, now. So therefore, so A 2022 term is equal to how much? 2022 only. Tan inverse of 2022 minus tan inverse of 1. Understand? Why A 2022 term is 2022 means here, see here, first term is 1, common difference is 1. That means 1 will be added. Okay, now, right. So next, write down this formula. So this is equal to tan inverse of 2022 minus 1 by 1 plus 2022 into 1. So this is equal to tan inverse of 2021 by 2023. So tan inverse of 2021 by tan inverse of 2023 will be the final answer. Okay, now. So very nice problem this is. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. If P is a 3 by 3 matrix, P is a 3 by 3 matrix such that P transpose is equal to A into P minus A minus 1 into I, where A is not 1 or minus 1. That means on the whole A is not equal to -1 or 1. A is a constant. Okay, here P is a matrix. Then which of the following is true? That means adjoint of P is equal to 1 or P is a singular matrix, adjoint of P is greater than 1 by 2 or adjoint of P is greater than 1. Okay, if you know the what is the determinant of P, the problem will be over. Then first of all, now let us see the problem. So here what is P is a 3 by 3 matrix. Now what is given? P transpose is equal to AP minus A minus 1 into I. That's all. That is the information is given. Nothing is given. Nothing is given. So you can substitute in place of P transpose. You can substitute this value and you can bring all the terms to one side, and that also you can do. Otherwise, you can take a transpose on both sides. If you take a transpose on both sides, so P is equal to A into P transpose minus A minus I into I transpose is I only. Just to have taken transpose on both sides. Now, P transpose whole transpose is P, A constant. So, P is a matrix, therefore, P transpose. I is a matrix, I transpose I. Now, this is equal to P is equal to A into P transpose is given. How much? AP minus A minus 1 into I minus of A minus 1 into I. Okay, now? So, let us multiply A inside. So, what happens? So, P is equal to A square P minus A into A minus I minus A minus 1 into I. Okay, now? Very nice. Now, P is equal to, so this is a square P. Take a minus I common outside. So, if you take a minus I common outside, so here what remains here? A square minus A. So, here plus A minus 1 will come. Okay, now? So, you have taken A square minus 1 plus A minus 1. Any more cancellation? So, this is equal to minus A plus A cancel. So, let us bring this P. So, this is a P minus A square minus P. This also you bring this side. Otherwise, you can put like that, minus of A square minus 1 into I is equal to 0. Okay, now? Right. You can take a P common outside. You can take a P common outside. Here 1 minus A square. So, this is a 1 minus A square. Otherwise, plus A square minus 1 into I is equal to 0. So, this is a 1 minus A square. So, we have taken minus, you multiply inside. So, this is equal to 1 minus A square into I is equal to 0. Okay, now? Right. So, very clear now. So, this is equal to 1 minus A square is equal to 0, or if you take a factorization, P plus I is equal to 0. P plus I is equal to 0. Okay, now? Right. 1 minus I square is equal to 0. Therefore, A square is equal to 1. Therefore, A is equal to plus or minus. But it is given that A is neither 1 nor 1. That's why this can be cancelled. Therefore, P plus I is equal to 0. P is equal to minus I. P is equal to minus I. Therefore, what is a modulus of P is equal to 1. So, understand what is a modulus of P minus I. Let us check once again any more cancellation here, P minus any more cancellations. So, here P transpose is equal to A minus P, A minus into A. So, any more? Right. A square P minus A into here. Here we have taken minus common outside. So, if you have taken minus common outside, so here A square minus A. Here there A minus 1. Minus minus cancel here, A square minus 1. So, here when you are taking A square minus 1, here it will be plus, no? So, you are taking A square minus of A square minus 1, it will become plus here. This here minus only you will get here, minus only. So, this is a square minus only. So, this is if you bring this side plus here 1 minus A square, then it will become minus, and it is a 1 minus A square. Then 1 minus A square is 0, or 1 minus I, this is a 1 minus I. Therefore, P is nothing but identity matrix. P is nothing but, therefore, their determinant is equal to 1. Determinant is equal to 1. Therefore, P is a singular matrix, he is saying. That is wrong. Understand? So, next after determinant is equal to P is equal to 1, then we have the adjoint of P is nothing but 1 to the power of 2. That means modulus of P whole to the power of n minus 1. That is modulus of P whole to the power of n minus 1. That is a modulus of P is 1 to the power of n minus 1. N means what? Order of the matrix 3 by 3. 3 minus 1, 2. 2, that is equal to 1. Therefore, adjoint of P is equal to 1. Adjoint of P is equal to 1. That is the answer. Okay. So, very nice problem. So, somewhat otherwise P transpose is equal to, you can do direct substitute also you can do. So, I hope that you enjoyed this problem. So, let us move to next problem. Hi students, welcome to this problem. This problem solution may be somewhat lengthy, but very easy one, very easy one. Let us see this problem. If dy by dx is equal to minus of x square plus 3y square by 3x square plus y square is equal to y square, and y of 1 is equal to 0, then the solutions options are also given. So, let us see the solution. Clearly, this is a homogeneous equation. So, this is a homogeneous equation. Let us put immediately substitution is put y is equal to vx. So, this is equal to dy by dx is equal to v plus x into dv by dx. Okay, na? So, immediate substitution. So, this is equal to v plus x into dv by dx is equal to minus of x square plus 3y square means what? 3v square x square by 3x square plus y square means v square x square. So, this implies v plus x into dv by dx is equal to minus of, see here in the numerator you can take x square common outside, denominator also you can take x square common outside, you can cancel. So, this becomes 1 plus 3v square by 3 plus v square. Okay, now right. Let us take to v2 right hand side. So, this is equal to variable separable method. dv by dx is equal to minus of 1 plus 3v square by 3 plus v square minus v taken to right hand side. So, what is a LCM? 3 plus v square. So, this is a minus 1, this is a minus 1 minus 3v square minus 3v minus v into v square v cube, minus 1 minus 3v square minus 3v minus v cube by 3 plus v square. Any more cancellations is there? So, nothing is cancelled. Okay. So, nothing is cancelled. Let us convert into variable and separable method. Okay, now we will do one thing here. So, we observe here. So, that is equal to x plus dv by dx. Let us take minus common outside. If you take a minus common outside, so if you observe here, v cube plus 3v square plus 3v plus 1 by 3 plus v square. So, in the numerator we have taken minus common outside. So, if you observe, up to here, see here, v cube plus 3v square plus 3v plus 1 is nothing but, so this is a x into dv by dx. This is nothing but v plus 1 whole cube, v plus 1 whole cube, a plus b whole cube, a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube, 1 cube 1. Understand? So, if you catch that point, the problem is over. Now, variable separable method. Variable separable method, bring all y v's to one side, all x to one side. So, this is equal to 3 plus v square by v plus 1 whole cube is equal to minus 1 by x dx, of course dv. So, at this situation, if you directly do this, right hand side is okay. Integral of 1 by x is means log x, that is over. But coming to the left hand side part only, you should be very careful. Left hand side part, in the numerator we got 3 plus v square, in the denominator v plus 1 whole cube v there. So, then what shall we do? So, what shall we do? So, we will do one thing. So, that is equal to put v plus 1 is equal to some t. V plus 1 is equal to, so left or right hand side, okay, forget about right hand side, left hand side. Put v plus 1 is equal to t, therefore, dv is equal to dt. dv is equal to dt, and here substitute in place of v, substitute t minus 1 whole square. In place of v plus 1, substitute t cube and separate it. We will get easily the remaining part. Okay. Let us continue the solution. Welcome back. So here, see here, those are the last steps. Integral 3 plus in place of v, can I substitute t minus 1 s. So this is a t minus 1 whole square by, in place of v plus 1, what you have to substitute? T. This is t cube into dt is equal to minus 1 by x dx. So this is equal to 3 plus t square minus 2t plus 1 by t cube dt is equal to minus 1 by x dx. Okay now. So let us separate here. So if we separate here, this is a 3 times 3 into t to the power of minus 3 plus this is equal to 1 by t minus 2 into t by t cube means t to the power of minus 2 plus t to the power of minus 3. Okay na, 3 to the power of minus 3 dt is equal to minus 1 by x dx. So now let us apply the integration formula. So this is equal to 3 into t to the power of minus 3 plus 1, that is equal to minus 2 by minus 2 plus this is equal to ln t log of t or ln t log of modulus of t minus 2 into t to the power of minus 2 plus 1, that is equal to minus 1 by minus 1 plus d to the power of minus 2 by minus 2 is equal to minus ln x plus ln c, minus ln x plus ln c or c. We can put here this side no logarithms, no. So this is a c. Okay now. Now let us do the remaining calculation. Right. So this is equal to how much? Minus 3 by 2. So this is equal to minus 3 by 2 t square plus ln of modulus of t, ln of modulus of t minus, already minus is there, minus into minus plus 2 upon t. This is a minus 1 by 2 square is equal to minus ln x plus c. Okay now. See here, minus 3 by 2 minus 1 by 2 minus 3 minus 4 minus 4 minus 3 minus 1 minus 4 minus 4 by 2 minus 2. So on the whole this is a minus 2 by t square plus ln of t plus 2 by t minus ln of x plus c. Now what is t? What is t? Already we have taken v plus 1. So that is equal to t is equal to v plus 1. What is v? So y is equal to vx, therefore v is equal to y by x plus 1. So on the, so actually t is equal to v plus 1 we have substituted. Again v is equal to y is equal to vx, no, therefore v is equal to y by x. On the whole, in place of t, substitute y by x plus 1. So that is equal to minus 2 by y by x. This is a y by x plus 1 whole square plus ln of t means y by x plus 1 plus 2 by y by x plus 1 is equal to minus ln x plus c. Okay now, right. Let us see here. Y of, now we have to find out the value of c. For this given here it is a y of 1 means what? This is a x value with the y value. X is equal to 1, y is equal to 0. Let us see here. Now this is equal to minus 2 by, see here, minus 2 by, so ln of t, 1 by t we got. So here t square by t cube 1 by t. Okay. So here y by x, 0 by x, 0 by x is equal to how much? 0. 0 plus 1, 1, 1 square 1 plus ln of y by x. Y by x is means how much? 0. Y by x means what? 0 by 1, 0. So ln of 0 we got, so that is equal to, so this is a ln of y by x, ln of y by x plus 1, ln of y by x plus 1, that means 1 you will get, ln of y by x plus 1 plus 2 upon y by x means 0, 0 plus 1, 0 plus 1 minus ln of 1, ln of 1 plus c. So, see this answer ultimately ln log c value. So, this is a minus 2, this is a log 1 0, this is a plus 2, this is 0 plus c, minus 2 plus 2. Ultimately how much we got? C is equal to 0 we got. So, here we got C is equal to 0. Let us substitute C is equal to 0 and we will get the remaining solution. That is all. Simply put, C is equal to 0 here. So, this is a log of x plus y by x. Here also you simplify this and we will take all the terms to one side. Okay. So, very easy to solve this problem. So, I hope that you understand this. Final answer will be, so I will give the final answer. So, here the final, after simplification we will get the final answer ln of x plus y is equal to minus 2xy upon x plus y whole square. So, this is the final answer. So, dear students, I hope that you enjoyed today's class. So, what are the problems given in the previous JEE mains examination? Just a few problems I have taken. So, with some more problems tomorrow's class I will present before you. So, until then, all the best for your exams.